Hi, now we are studying how to evaluate definite integrals of type 4, which is integrals of the form integral minus infinity to infinity r of x into e raised to ix dx, where degree of the denominator of r of x is only one unit higher than that of the degree of the numerator, and r of z has no real poles. Method of integration. Choose gamma as the perimeter of the rectangle with the vertices x2 plus iy minus x1 plus iy and minus x1. That is this part, perimeter of this rectangle. When x1, x2 and y sufficiently large, gamma encloses all poles of r of z into e raised to iz in the upper half plane. When x1, x2 and y tends to infinity, the integral over the upper horizontal side, that is along this side, and the integrals of the vertical sides, that is these two sides, tends to 0. Therefore, integral over gamma r of z into e raised to iz dz becomes integral minus infinity to infinity r of x into e raised to ix dx plus 0, where x1, x2 and y tends to infinity. Therefore, by residue theorem, integral minus infinity to infinity r of x into e raised to ix dx is integral over gamma r of z into e raised to iz dz, which is 2 pi I into sigma over y greater than 0 residue of r of z into e raised to iz. Now there is one question, which is evaluate integral 0 to infinity x sin x by x square plus a square dx. For this we proceed as before. Choose gamma as the perimeter of the rectangle with the vertices x2 plus iy minus x1 plus iy and minus x1. When x1, x2 and y are sufficiently large, gamma encloses all poles of r of z into e raised to iz in the upper half plane. When x1, x2 and y tends to infinity, the integral over the upper horizontal side and the integrals of the vertical sides tends to 0. Therefore, integral over gamma r of z into e raised to iz dz equal to integral minus infinity to infinity r of x into e raised to ix dx, where x1, x2 and y tends to infinity. Therefore, by residue theorem, integral minus infinity to infinity r of x into e raised to ix is 2 pi I into sigma y greater than 0 residue of r of z into e raised to iz. Now let I equal to the given integral 0 to infinity x sin x by x square plus a square dx. Now x sin x is imaginary part of x e raised to ix. Therefore this integral can be written as half of imaginary part of integral minus infinity to infinity x e raised to ix by x square plus a square dx, which is equal to half of imaginary part of this integral is 2 pi I into sigma over y greater than 0 residue of r of z into e raised to iz, which is equation 1. Now we find residue of r of z into e raised to iz. Now r of z into e raised to iz is z by z square plus a square into e raised to iz, which is z e raised to iz by z plus ai into z minus ai. Therefore, poles of r of z into e raised to iz are the zeros of z square plus a square, which are z equal to plus or minus ai. Here z equal to ai lies in the upper half plane. Therefore, residue of r of z into e raised to iz at z equal to ai equal to limit z tends to ai residue of r of z into e raised to iz into z minus ai, which is equal to limit z tends to ai z e raised to iz by z plus ai into z minus ai into z minus ai. Z minus ai cancelled. Therefore, this is equal to limit z tends to ai z e raised to iz by z plus ai. Substituting ai, we get this as ai into e raised to minus a by 2ai. Cancelling ai, this is equal to e raised to minus a by 2. Therefore, substituting this in 1, we get I equal to half of imaginary part of 2 pi I into sigma over y greater than 0 residue of r of z into e raised to iz, which is equal to half of imaginary part of 2 pi I into residue of r of z into e raised to iz is e raised to minus a by 2, which is substituted here. Cancelling 2, which is half of imaginary part of pi I e raised to minus a, which is equal to pi e raised to minus a by 2. Thank you.